After learning differentiation techniques, today I'm very excited to show you how we can apply differentiation. Hence, for today's lesson, lesson 13, applications of differentiation. This video is brought to you by Ace with Tennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. First, we learn tangent and normal to a curve. Here is the curve with the equation y equals to fx, and this is a point. Any point on the curve, we label it as point P. Tangent to the curve at point P, we'll draw a straight line touching point P. This is the tangent. Normal to the curve at point P, so normal will be perpendicular to the tangent. This is normal. So tangent is perpendicular to normal, therefore the gradient of the tangent multiplied with the gradient of the normal equals to -1. General equation of a straight line, which we have learned in coordinates geometry, is y minus y1 equals mx minus x1. Hence, equation of a tangent will be y minus y1 equals m tangent bracket x minus x1. Equation of a normal will be y minus y1 equals m normal bracket x minus x1, where the coordinates of P will be x1, y1. The gradient of tangent is equal dy over dx. If y equals fx is an increasing function, therefore the gradient of tangent equals dy over dx is greater than 0. If y equals to fx is a decreasing function, therefore the gradient of the tangent equals dy over dx less than 0. After you have learned the concept of tangent and normal to a curve, let's try to solve some questions. Here is one example. The equation of a curve is given by y equals 6 over 2x squared plus 1. Find a dy over dx. B. The equation of the tangent and the normal to the curve at the point where x equals to -1. Here is the solution. For A, given that the y equals 6 bracket 2x squared plus 1 to the power of -1. Remember, before we want to do differentiation, we need to leave the equation in indices form. Now we can start to do the differentiation, right? Power bring down, copy the bracket, power -1, and differentiate the bracket. Hence, for this case, we get dy over dx equals -6 times 2x squared plus 1 to the power of -2 times 4x. Simplify, we get -24x over 2x squared plus 1 squared. For B, when x goes to -1, y is equal 6 over 2 times -1 squared plus 1, which is 2. So, the gradient of the tangent equals dy over dx. We substitute x equals to -1 into dy over dx, we get -24 times -1 over bracket 2 times -1 square plus 1 square. And we get the gradient of the tangent equals 8 over 3. So now we want to find the equation of the tangent, which is y minus y1 equals mt bracket x minus x1. Substitute all the values. Y minus 2 equals 8 over 3 times x plus 1. And then we make y the subject. It becomes y equals 8 over 3x plus 14 over 3. This is the equation of tangent. Similarly, to find the equation of the normal, first we need to find the gradient of normal. From this equation, mt times mn equals -1, mn will be negative 3 over 8. So to get the equation of the normal, we use this equation y minus y1 equals to mn x minus x1. So y minus 2 equals negative 3 over 8 times x plus 1. Then we make y the subject. It becomes y equals negative 3 over 8x plus 13 over 8. So this is the equation of normal. Now you can try this example yourself. Given that the tangent to the curve y equals to p over x squared plus qx minus 1 at point negative 1, negative 3 is parallel to the line y equals 14x plus 4, find the value of p and q. You can pause the video and try to solve it yourself. Here's the solution. So now you want to find the value of p and q, which means you have two unknowns. Then you need to have two equations so that you can solve simultaneous equation to get the values of p and q. Right? So now, given that the coordinates is negative 1 and negative 3, which means when x is negative 1, y is negative 3. So we substitute these values into the equation of the curve given, which is y equals to p over x squared plus qx minus 1. It becomes negative 3 equals p over negative 1 squared plus q negative 1 minus 1. Simplify this equation, we get p minus q equals negative 2. We label this equation as the first equation. Okay, next, we can rewrite this equation into indices form, which is y equals to px to the power of negative 2 plus qx minus 1. Then we differentiate this equation dy over dx equals negative 2p x to the power of negative 3 plus q. Simplify, you get negative 2 over p, negative 2p over x cubed plus q. So it is given that the tangent is parallel to the line y equals 14x plus 4, which means they have the same gradient. So where is the gradient? This is the gradient. So we know that the gradient of the tangent equals 14, and dy of dx is the gradient of the tangent, which equals to 14. So it is negative 2p over x cubed plus q equals to 14. X is negative 1, hence it becomes negative 2p over negative 1 cubed plus q equals 14, and we get 2p plus q equals to 14. We label this equation as equation number 2. Now we can start to solve simultaneous equation. We can say that equation 1 plus equation 2, we get 3p equals 12. So this is equation 1, which is here, and this is equation 2. So p plus 2p, so p plus 2p, we get 3p, minus p plus p minus q plus q is 0. Negative 2 plus 14, we get 12. Alright, so 12 is here. Then from here, p is 4. So we can substitute p equals 4 into the first equation, right, which is p minus q equals negative 2. Then it is 4 minus q equals negative 2. Q will be equals 4. So we have found the value of p and q. Increasing and decreasing functions. Example. Determine whether y equals negative 5x over x squared plus 1 is an increasing function or a decreasing function for x greater than 1. Here's the solution. Given the equation y equals negative 5x over x squared plus 1, so we want to differentiate this equation. We can apply Quotient Rule, which becomes x squared plus 1 times negative 5 minus negative 5x times 2x over x squared plus 1 squared. Alright, so how we get this? Remember, this is quotient rule. V times du over dx minus u times dv over dx over v squared. Then we simplify, it becomes negative 5x squared minus 5 plus 10x squared over x squared plus 1 squared, which is 5x squared minus 5 over x squared plus 1 squared. For x greater than 1, we look at this equation, we can see that 5x squared minus 5 is greater than 0. And x squared plus 1 square is greater than 0. Okay, the reason is because since this whole term, it is square, so it doesn't matter whether the value inside the bracket is a positive value or negative value, it will always be positive. And for this case, since x squared is greater than 1, the x is greater than 1, so this value will always be greater than 0. Therefore, we can say that dy over dx is greater than 0, hence y is a increasing function. Now, let's try this example yourself. Given that y equals x cubed minus half x squared minus 2x plus 1, find the range of the values of x for which y increases as x increases. You can pause the video and try to solve it yourself. Okay, here's the solution. Given that y equals x cubed minus half x squared minus 2x plus 1, so we can differentiate this equation. Dy over dx equals 3x squared minus x minus 2. So it mentioned that y increases as x increases, which means it is an increasing function. Therefore, dy over dx is greater than 0. Hence, 3x squared minus x minus 2 is greater than 0. Then from here, we need to solve quadratic inequalities. So we factorize, it becomes x minus 1 times 3x plus 2 greater than 0. Now we can draw the number line, which this is negative 2 over 3, this is 1. It is a smiley face, and it is greater than 0, so it will be above the x-axis, which is this region and this region. Hence, x is less than negative 2 over 3, or x is greater than 1. Now let's discuss about the rate of change. Here are a few concepts that you need to understand. If the variable x changes with time t, then x equals ft. The rate of change of x is defined as dx over dt, which is equals f prime t. Hence, the rate of change of y can be determined by applying chain rule, which is dy over dt equals dy over dx times dx over dt. I hope you still remember the chain rule that we have discussed in the previous lesson. If the dependent variable y has relationship to more than one variable, say a and b, then the rate of change of y can be determined by dy over dt equals dy over dA times dA over dB times dB over dt. You don't have to memorize this equation. You just need to understand the chain rule concept. So from here, dy is the starting point and dt is the ending point. So when we want to write the equation, it will start with dy and end with dt. Next, when it is over dA for the first differentiation, then the second differentiation must start with dA. And the second differentiation is over dB, then the next differentiation must start with dB. Okay, so this is the chain rule. Positive rate of change indicates that the amount of the quantity involved increases over the time, while negative rate of change indicates that the amount of quantity involved decreases over the time. Constant rate of change indicates that the amount of quantity involved changes at a steady rate. Okay, so please remember the keywords here: positive rate, negative rate, constant rate. Now, let's look at this example. Two variables, x and y, are related by the equation y equals 2x squared over 1 plus x. Given that y increases at a rate of 3 units per second, find the rate of change of x when x equals to 3. Here's the solution. So, given that dy over dt equals 3 units per second, which means it is a constant rate. And the equation y equals 2x squared over 1 plus x. Now we want to differentiate this equation, which is dy over dx equals 1 plus x times 4x minus 2x squared times 1 over 1 plus x squared. So we actually apply the quotient rule. Then we simplify further, we get 4x plus 4x squared minus 2x squared, and it is equal to 2x squared plus 4x over 1 plus x squared. Next, we can now find what they want us to find, which is the rate of change of x. So when you see the word the rate of change of x, then it will be dx over dt, which is this one. The chain rule that we know is dy over dt equals dy over dx times dx over dt. Just put in all the values given. Dy over dt is 3, dy over dx is 2x squared plus 4x over 1 plus x squared. And when x, we can make dx over dt the subject, which gives us 3 times 1 plus x squared over 2x squared plus 4x. When x is 3, then our dx over dt will be equals 3 bracket 1 plus 3 squared over 2 times 3 squared plus 4 times 3. So when press calculator, we get 48 over 30 or 1.6. And it is the rate of change of x when x goes to 3 is 1.6 units per second. Now, you can try this example yourself. Given that y equals 3x plus 4 over x minus 2 and x is greater than 0, find dy over dx. Then A, hence show that y is a decreasing function. B, given that x and y vary with time t, find the value of x for which 2 dy over dt plus 5 dx over dt equals 0. You can pause the video and try to solve it yourself. Okay, now let's look at the solution. So we know that the equation is y equals 3x plus 4 over x minus 2. Well, we want to find the dy over dx, we need to apply quotient rule. So dy over dx will be v du over dx minus u dv over dx over v squared, which is x minus 2 times 3 minus 3x plus 4 times 1 over x minus 2 squared. Expand, we get 3x minus 6 minus 3x minus 4 over x minus 2 squared. Okay, and we get dy over dx equals negative 10 over x minus 2 squared. Okay, now we move on to A. So show that dy over y is a decreasing function. We look at this dy over dx, right? The denominator x minus 2 squared is a positive value because of the square. and hence dy over dx is negative 10 over x minus 2 square, right? It is less than 0. So from here, we can make the conclusion that y is a decreasing function. Okay, then shown. Next for b, so we can apply the chain rule dy over dt equals dy over dx times dx over dt. Okay, so substitute dy over dx as negative 10 over x minus 2 square times dx over dt. So from here, we copy the equation given 2 times dy over dt plus 5 dx over dt equal to 0. So now substitute the value of dy over dt, right, with negative 10 over x minus 2 square dx over dt. Okay, then we simplify, we get negative 20 over x minus 2 square dx over dt plus 5 dx over dt. Okay, so we can get that negative 20 over x minus 2 square plus 5 equal to 0. And now we solve this equation. It becomes 5 times x minus 2 square equals 20. So x minus 2 square is 4. X minus 2 equals 2, or x minus 2 equals negative 2. Hence x is 4 or x is 2. Okay, we know that x must be greater than 0, then we reject this answer. Now let's look at one example about the application of rate of change. Here is the example. A cube of ice is melting at a constant rate. The initial volume of the ice cube is 20 cm cube and the volume after 5 minutes is 15 cm cube. Find the rate at which the length of the cube is decreasing at the time t equals 12 minutes. Here is the solution. So it is a constant rate of change of volume. Okay, it is mentioned here, constant rate. So it is the constant rate of change of volume. Therefore, we can write dv over dt equals change in volume over change in time. Okay, so at first it is 20 cm cube, and after 5 minutes it is 15 cm cube. So the rate of change of volume for this case will be 15 minus 20 over 5, which gives us negative 1 cm cube per minute. Notice that negative rate means the rate is decreasing. So now this is a cube. The size, the shape of the ice is a cube. So we let x to be the length of the side of the cube. Now look at this diagram. So this is x. The volume will be x cubed. Hence dv over dx will be 3x squared. Now we apply the chain rule. dv over dt equals dv over dx times dx over dt. So substitute dv over dt as negative 1, which is this one. Okay, dv over dx is 3x squared, which we get from here, times dx over dt. We can get dx over dt equals negative 1 over 3x squared. Okay, when t is 12, the change in volume will be negative 1 times 12. Okay, which is negative 12 cm cube. So the volume V will be 20 minus 12, and we get 8 cm cube. So it means that x cube equals to 8 and the x is 2. So from here, we can substitute x equal to 2 into our dx over dt, which becomes negative 1 over 3 times 2 square, and the answer for dx over dt is equals negative 1 over 12 cm per minute. This is the answer. So we can say that the length decreases at the rate of 1 over 12 cm per minute. Okay, so look at here. It is a negative value. then we can write in sentence to say that it decreases at this rate. Now you can try this example yourself. A spherical balloon is being inflated in such a way that its volume is increasing at a constant rate of 150 cm3 per second. At time t seconds, the radius of the balloon is r cm. Given that the volume of a sphere is 4/3 pi r cubed and the total surface area is 4 pi r squared, find the rate of change of the radius and the surface area at the instant where the radius is 50 cm. Okay, you can pause the video and try to solve it yourself. Okay, here is the solution. The first one, right? Now let's see what information is given. So we know that the volume is 4/3 pi r cubed, so which is given, and this is a spherical balloon. So that's why the volume of a sphere formula is 4/3 pi r cubed. And we can differentiate this volume, dv over dr equals 4 pi r squared. Then we can apply the chain rule, dv over dt equals dv over dr times dr over dt. We want to find dr over dt. Okay, so dv over dt is 150 because it is given increasing at a constant rate of 150 cm3 per seconds. So dv over dr we get from here, which gives us 4 pi r squared times dr over dt. And given that r is 50, so substitute inside the equation, it becomes 150 equals 4 pi times 50 squared times dr over dt. Hence, dr dt equals 150 over 4 pi times 50 squared, and the answer is 3 over 200 pi cm per seconds. Solution for part 2. Given that the area is 4 pi r squared, so we actually just do the similar steps. We differentiate the area, dA over dr equals 8 pi r. Hence, dA over dt equals dA over dr times dr over dt. So, dA over dr is 8 pi r. dr over dt, which is this one, we have already found in part 1. It is 3 over 200 pi. Okay, we can simplify dA over dt becomes 3 over 25 r. Then we substitute r equals to 50, dA over dt equals 3 over 25 times 50, which gives us 6 cm squared per second. This is the answer. Okay, now we look at another application of rate of change in a specific shape, which is cone. Here is the example. So if we have a cone and the diagram is given this, so the question is, the diagram shows a conical container initially full of height 12 cm and radius 4 cm. Water is being pumped up of the container through an opening at the base of the container at a rate of 8 cm3 per second. After t seconds, the depth of the water is h cm. 1. Show that the volume of the water in the container v cm3 at time t seconds is given by v equals 64 pi minus pi over 27 times 12 minus h cubed. 2. Find the rate of change of the depth when the volume of water in the container is 37 pi cm3. 3. State with a reason whether this rate will increase or decrease as t increases. Okay, here's the solution. So now we can, to get the volume of the water, the basic idea is we get the volume of the big cone minus the volume of the smaller cone. Okay, so I will label this radius as R. Okay, we will apply similar triangle concept. So this is a triangle. Okay, this is the height, which is 12 cm. So this is the radius, which is 4 cm. Okay, this is the radius R. This is the height, and this is the h. Okay, so from here, this length will be 12 minus h. Can you see the small triangle and the big triangle? So let me show you first, right? So this is the small triangle with the base as R, the height is 12h, 12 minus h. And then the next one, this is the bigger triangle with the radius as 4 and the height is 12. Okay, so these two triangles are similar. Then the ratio of their height to the radius is equal. So now the height to the radius of the smaller triangle will be 12 minus h over r. The height to the radius of the big triangle will be 12 over 4, and both are equal. Hence, we get this equation, 12 minus h over r equals 12 over 4. Okay, we rearrange this equation, which we get 12 minus h equals 3r, and we make r the subject. R equals 12 minus h over 3. Okay, so why do we want to do this step? Because we look at the equation that we want to prove, there is no r, hence we need to eliminate r. Okay, so next we can now show the volume, right? So first, the volume of the cone formula will be 1 over 3 pi r square h. So the volume of the big cone will be 1 over 3 pi, the radius is 4, so it's 4 square, the height is 12, so times 12, and the volume of the big cone will be 64 pi. The volume of the small cone will be 1 over 3 pi, and the radius is 12 minus h over 3 square, which we have already gotten here. Okay, so remember, right? And then the height will be 12 minus h. So which is this one. Okay, then from here we can simplify this equation, which becomes pi over 27 times 12 minus h cubed. So we want to find the volume of the water, which is the volume of the big cone minus the volume of the small cone, which is 64 pi minus pi over 27 times 12 minus h cubed. And you can see that it is the same answer that we need to show, hence shown. Okay, now let's move on to solution for number 2. So I want to find the rate of change of depth when the volume of water container is 37 cm cubed. So this is the volume, 37 pi, right? Then equals 64 pi minus pi over 27 times 12 minus h cubed. So from here, we can solve this equation to get the h value. Okay, so simplify, we get this, and the next one is 12 minus h cubed equals 729. So 12 minus h equals to 9, therefore h equals to 3. Okay, now volume equation is 64 pi minus pi over 27 times 12 minus h cubed. So we differentiate dv over dh equals negative pi over 27 times 3 times 12 minus h squared minus 1. Okay, now how we get this, right? Look at the equation of the volume, right? So differentiate the constant, we get 0. Okay, then we want to differentiate this part, so power bring down. Okay, which is here, and then power we copy the bracket first, 12 minus h, and then power minus 1, so 3 minus 1 we get 2 here. Then after that, differentiate the bracket, so differentiate 12 we get 0, differentiate negative h we get negative 1. Okay, then from here we simplify, we get pi over 9 bracket 12 minus h squared. Okay, now we can form the chain rule. dv over dt equals dv over dh times dh over dt. So we know dv over dt is negative 8, dv over dh is pi over 9 times 12 minus h squared times dh over dt. Alright, so we want to find this one. We substitute h equals to 3 into the equation, which we get this negative 8 equals pi over 9 times 12 minus 3 squared times dh over dt. So solve it, we get dh over dt equals to negative 8 over 9 pi cm per seconds. Alright, so here is solution number 3. So what state will reason whether this rate will increase or decrease when as the t increases. Now we see that the dh over dt is less than 0. Okay, so what can you make a conclusion here? We can say that this rate will decrease as t increases. The next application of differentiation that we want to learn is stationary points and differentiation. Here is the concept that you need to know. A curve changes its state of function at stationary points. At a certain stationary point, let's say x0 and y0 coordinates of a curve y equals to fx, the gradient of the tangent at this point is 0. That is, dy over dx is equal to 0 when x equals to x0. There are 3 types of stationary points that you will get: maximum point, minimum point, and point of inflection. So to illustrate the points, so we have this curve. This point will be the maximum point. And when we draw a tangent, so we see that this part before the maximum point, the graph is an increasing function, and after the maximum point, the graph is a decreasing function. Okay, so the second types of stationary point will be the minimum point. So this is the minimum point, and we can draw a tangent passing this point. So it is a horizontal line, which means that the gradient is 0. We can see that before this minimum point, the graph is a decreasing function. After the minimum point, the graph is an increasing function. So we can say that the curve has changed its state of function, right, from decreasing function to increasing function at minimum point. Okay, so now move on to the inflection points. There are 2 types. This is the first type. Okay, so this is the point of inflection, and we can draw a tangent which looks like this. It is a horizontal line and the gradient is 0. Okay, and you can see that this is an increasing function but with decreasing gradient. So this is before the point of inflection. Then after the point of inflection, the graph becomes increasing function with increasing gradients. Okay, then this is the second type of inflection point. So this is the inflection point with the tangent drawn here. It is a horizontal line again, which means that the gradient or dy or dx is equal to 0. Alright, so this point, after the point of inflection, it is a decreasing function with increasing gradient. Before the point of inflection, it is decreasing function with decreasing gradient. Alright, so again, the state of the graph or the curve changes at the point of inflection. You have understood that there are 4 types of stationary points. Now, let's learn how we can determine the nature of the stationary points with the first method, which is called the first derivative test. Okay, so let's look at the case 1, right? Okay, if for example we have y equals to negative x squared, so how we want to know what type of stationary point that we can get from this graph? So firstly, we have to differentiate this equation, dy over dx equals to negative 2x. So when dy over dx equal to 0, so x will be equal to 0. Okay, so hence y is equal to 0. Therefore, the coordinates of the stationary point will be at 0, 0. Okay, now, can you tell what type of stationary point is this? So it is quite difficult to know the stationary point, right? So what we can do is we can draw a table which looks like this. Okay, we label this as x. So x to 0 we put in at the center here. Okay, after that, the next row is dy over dx, which we get 0 when the x is 0. Okay, when the dy dx is 0 because this is a stationary point, and the slope is a horizontal line since dy over dx is 0. Okay, so the next step, what we need to do is, right, we go and choose a point that is very close to 0 but less than 0. Okay, let's say I choose the x negative as negative 0.01. Okay, so again, which is very close to 0 but less than 0. Okay, now I substitute this value into dy over dx here. I will get a positive value. So then it is a greater than 0. Dy over dx is greater than 0. So I don't have to really calculate the exact value. Just look at the sign. Okay, so if x negative is negative 0.01, dy over dx is a positive number. So it's greater than 0. Next, the slope, it will be an increasing function, means it will go up like this. So next step, I want to choose a value which is close to 0 but slightly larger than 0. Okay, so I choose x plus as 0.01. Then I substitute again into the equation dy over dx. Here, I find that I get a negative value. So again, I don't have to find the exact value when I substitute 0.01. I just need to look at the sign. So x plus is a positive number times with a negative 2. I will get a negative number which is less than 0. The slope will be a decreasing function which goes down like this. Okay, so from here you can see that it is a set phase graph. I will always say that this is a set phase graph. So the type of the stationary point will be a maximum point. So this is case 1. Now let's talk about case 2. A simple example is y equals to x squared. So we do exactly the same steps, right? So first step, differentiate it, dy over dx equals to 2x. So when dy over dx equal to 0, because it is a stationary point, right? So we get that x equals 0, y is 0. So now the coordinates of the stationary point will be 0, 0. Okay, repeat the same process. We draw this table and we label this as x, which when the x is 0, we put inside the center. We put at the center here. Dy over dx, it is 0 as well because it's a stationary point. The slope we need to determine. Right now, the next step. Okay, the slope is a horizontal line when dy over dx is 0. The next step is I want to choose a number or a value which is very close to 0 but less than 0. Let's choose x minus is negative 0.01. Then I substitute into dy over dx. Okay, and for this case, I get a negative value which is less than 0. Now again, I don't have to find the exact value. I just want to look at the sign. So 2 is a positive number times if negative number, I will get a negative number. So it is less than 0. So the slope will be going downwards, a decreasing function. Next, I will choose a number which is very close to 0 but slightly bigger than 0. Okay, let's choose x plus as 0.01. Again, I substitute inside this dy over dx. So I don't have to find the exact value, just need to look at the sign. So 2 is a positive number, x plus is a positive number. So I will get a positive number, then dy over dx will be greater than 0. So the slope will be going up. It's an increasing function, right? So it is a smiley face. The type of the stationary point will be a minimum point. Okay, how about case number 3, right? So for example, I have this y equals to x cubed. So again, we repeat the same step, exactly the same step. We differentiate the y, dy over dx, we get 3x squared. So when dy over dx equal to 0, because it's a stationary point, right? So we solve this equation, we get x equal to 0. So when x equals 0, y is also equal to 0, where we put inside this equation to get the y. So we can say that the stationary point coordinates is 0, 0. Okay, now I want to determine the types of stationary point. So I have to draw this table. Okay, label this x. When x was 0, put the value in the center. Then after that, move on, dy or dx is 0 as well. And the slope, right, when dy dx is 0, gradient is 0, it is a horizontal line. Okay, so next thing is I want to choose one value, right, very close to 0 but less than 0. Let's choose x minus 1, x negative as negative 0.01. Substitute this value into the dy over dx. Okay, don't have to find the exact value, but just need to look at the sign, right? So this is, look at here, right, x squared. So even if x is a negative value, after I square it becomes a positive. So it will be a positive number times 3, also a positive number. That's why dy or dx will be a positive. Therefore, it is greater than 0. So the slope will be increasing function going up like this. All right. Now, next step, I also choose one number, right, which is very close to 0 but slightly bigger than 0. Let's choose x plus as 0.01. Again, substitute into this equation. Don't have to find the exact value, just need to look at the sign. So positive, then I square is still a positive. So positive times 3, a positive number, I will still get a positive. So my dy of dx is greater than 0. The slope will be going up as well. Alright, so I can roughly sketch the graph which will look like this. Okay, so the type is the point of inflection. The type of the stationary point is a point of inflection. Okay, so now let's move on to case number 4. Right, let's look at the example, simple example, right, is when y equals to negative x cubed. So again, we repeat the same step. Dy over dx equals negative 3x squared. So when dy over dx equal to 0, now we want to find the coordinates of the stationary point. So dy over dx will equal to 0, x will be 0, y will be 0. So the coordinates of the stationary point will be 0 and 0. Next, draw this table. So label this as x, and when x was 0, put at the center. Dy over dx, put the value equal to 0 at the center. And then the slope, right, when dy dx is 0, it is horizontal line. Okay, next step, choose a value which is close to 0 but slightly smaller than 0. Let's choose x minus as negative 0.01. So let's update here, right? This is a square. So when x minus is negative, when a square it becomes positive, and then multiply with negative 3, it is a negative number. So that's why dy over dx will be less than 0. Okay, and the slope will be going down. It's a decreasing function. Next, again, choose a value which is very close to 0 but slightly bigger than 0. Let's choose x plus as 0.01. Then I substitute into dy over dx again, right? So this is a positive number, square, it becomes a positive. Then it multiply with negative 3, it becomes a negative value. So I don't have to find the exact value, just need to look at the sign. I find that dy over dx is less than 0. So it is a decreasing function. The slope will go down. Okay, now I can tell what is the type of the stationary point. So roughly sketch it, it looks like this, and it is a point of inflection. Now, let's talk about the second method to determine the nature of stationary points, which is called second derivative test. Here is the strategy. Step 1. Determine dy over dx. Step 2. Let dy over dx equals 0 and determine the coordinates of stationary point x0, y0. Step 3. Determine d squared y over dx squared. Step 4. Substitute x equal to x0 into d squared y over dx squared and check. If d squared y over dx squared is less than 0, stationary point is a maximum point. If d squared y over dx squared is greater than 0, then stationary point is a minimum point. However, if d squared y over dx squared equal to 0, stationary point can be a maximum point, minimum point, or point of inflection. Then we have to use first derivative test to determine the nature. Hence, second derivative test cannot determine point of inflection. Now, let's look at this example. The equation of the curve is given as y equals 8 over x squared plus x cubed over 6. Find the coordinates of the stationary point and hence determine the nature of the stationary point. Here is the solution. So it is given that the equation of the curve is y equals 8 over x squared plus x cubed over 6. We want to find dy over dx. But before that, we will have to change this equation into indices form, which is y equals 8x to the power of negative 2 plus 1 over 6 x cubed. And now we can find dy over dx, which is equals negative 16x to the power of negative 3 plus 3 over 6 x squared. And hence, we simplify this equation, dy over dx equals negative 1 over negative 16 over x cubed plus half x squared. Next, to find stationary point, we need to let dy over dx equals 0. Hence, negative 16 over x cubed plus 1 over 2 x squared equals to 0. We multiply x cubed for both sides, we get negative 16 plus 1 over 2 x to the power 5 equals 0, which means 1 over 2 x to the power 5 equals 16, and x to the power 5 equals 32. Hence, x equals 2. So this is the x coordinate of the stationary point. Now we want to find the y coordinate of the stationary point. So we just substitute x equals to 2 into the equation of the curve, which becomes y equals 8 over 2 squared plus 1 over 6 times 2 cubed. And we get y equals 3 and 1/3. So the coordinates of stationary point is 2, 3 and 1/3. Next, we get the second derivative, which is d squared y over dx squared. We get 48x to the power of negative 4 plus x. Or d squared y over dx squared equals 48 over x power 4 plus x. When x equals to 1, d squared y over dx squared equals 48 over 2 to the power 4 plus 2, and it is equals 5. From here, we find that d squared y over dx squared is greater than 0. Therefore, the stationary point is a minimum point. Now, you can try this example yourself. Find the coordinates of the stationary point of the curve with the equation y equals x cubed minus 3x squared plus 3x minus 7. Hence, determine the nature of the stationary point. You can pause the video and try to solve it yourself. Okay, here is the solution. Given the equation of curve is y equals x cubed minus 3x squared plus 3x minus 7, so we want to find dy over dx. So for this case, dy over dx is 3x squared minus 6x plus 3. To find the stationary point, we need to let dy over dx equals to 0. Therefore, 3x squared minus 6x plus 3 equal to 0. Then we divide 3 for both sides. We get x squared minus 2x plus 1 equals to 0. Then we can factorize this equation, which becomes x minus 1 squared equals to 0. X minus 1 is 0. Hence, x equals to 1. So this is the x-coordinate of the stationary point. Now we want to find the y-coordinate of the stationary point. We just need to substitute x equal to 1 into the equation of the curve, which we will get y equals 1 cubed minus 3 times 1 square plus 3 times 1 minus 7. And we get the answer y equals negative 6. Therefore, the stationary point is 1, negative 6. So the next step, we want to find the second derivative. So we just need to differentiate dy over dx. Then we get d square y over dx square. So we differentiate this and we get 6x minus 6. So we can substitute x equal to 1 into d square y over dx square, and we get 6 times 1 minus 6, which is 0. So now d square y over dx square is 0. We can't determine the nature of the stationary point. So we have to use the first derivative test. Okay, so still remember this table. The first step is we have to write the first row as x, the middle column as 1. So dy over dx will be equals to 0. The slope will be a horizontal line. Next, we want to find a value which is very close to 1 but slightly lower than 1. So let's choose x minus equals 0.99. So we substitute x equals 0.99 into dy over dx. So we don't have to find the actual value. From here, which is this equation, when you substitute x equals 0.99, we get a positive value for dy over dx. Hence, the slope will be an increasing line. So next, we choose another value which is close to 1 but slightly bigger than 1. So let's choose x plus as 1.01. Then we substitute x equals 1.01 into dy over dx. So this equation again. Okay, we don't have to find the actual value. We just need to see the sign. We find that dy over dx is greater than 0, which means it is an increasing function. So the slope will be going up as well. Alright, so hence, what's the type of this curve? So it is the point of inflection. Hence, we can say that the stationary point at x equals to 1 is a point of inflection. Now, let's discuss an example related to the problem on maxima and minima. Here is the example. Given this diagram, the diagram shows a rectangle of length x and two semicircles, each of radius r cm. The perimeter of the figure is 400 cm and the area of the rectangle is a cm square. A. Show that a equals 400r minus 2 pi r square. B. Find an expression for dA over dr. C. Calculate 1. The value of r for which a is a maximum. 2. The maximum value of a correct to 3 significant figures. Here is the solution. For a, given that the perimeter is 400, so from this figure, it is made up of two semicircles which becomes a circle and a rectangle. Therefore, the perimeter is 2 pi r plus 2x equals 400. Okay, so 2 pi r is the circumference of a circle, which is this semicircle and this semicircle. So they form a complete circle. Then for 2x, so this length is x and this length is x as well. So the perimeter become 2 pi r plus 2x equals 400. Next, we divide by 2 for both sides. We get pi r plus x equals 200. Hence, x equals 200 minus pi r. Now, we can find the area of the rectangle, which is a equals x times 2r. So this side is x, and this side will be 2r. Now we substitute x as 200 minus pi r, and the area becomes 200 minus pi r times 2r. Then we expand the equation, which will become 400r minus 2 pi r squared. So it is the same as the given equation then shown. For b, now we can differentiate the area. dA over dr equals 400 minus 4 pi r. For c, to find the value of r for which a is a maximum, so we have to check d square a over dr square equals negative 4 pi. So from here, d square a over dr square is less than 0, a is maximum. So now we can let dA over dr equals to 0, which means 400 minus 4 pi r equals to 0. So 4 pi r equals 400, r will be 100 over pi. So this is the value of r when a is a maximum. So for 2, find the maximum value of a. So you substitute r equals 100 over pi into the equation of the area, which is this one. So we get 400 times 100 over pi minus 2 pi times 100 over pi squared. And we get 6,370 cm squared to nearest 3 significant figures. Now, you can try this example yourself. A piece of wire is cut into 2 pieces, one of length x cm and the other of length x minus 10 cm. The piece of length x cm is bent to form a circle. The other piece is bent to form a square. Show that as x varies, the sum of the areas enclosed by these 2 pieces of wire is a minimum when the radius of the circle is 5 over pi plus 4 cm. You can pause the video and try to solve it yourself. Okay, here is the solution. Given that the piece of wire xcm is bent into form a circle, which means that x is the circumference of the circle, hence 2 pi r equals to x. From here, the r is x over 2 pi. Next, we can get the sum of the areas enclosed by these 2 pieces of wire, so which is one is circle and one is a square. So a circle and a square. Hence, a equals pi r square, which is the area of the circle, and x minus 10 over 4, this is the side of the square, as the length of the second piece of wire is x minus 10, so it is a square, we divide by 4. Okay, and then the area of the square is x minus 10 over 4 square. From here, we substitute r equals x over 2 pi into the equation, then we get this, and we expand the bracket here, we get x squared minus 20x plus 100 over 60. Then we can try to simplify. Okay, firstly, for the pi r square here, we expand the bracket, we get pi times x squared over 4 pi squared. And the fraction here, we break this fraction into 3 fractions, which is 1 over 16x squared minus 5 over 4x plus 25 over 4. Then we further simplify, we get x squared over 4 pi plus 1 over 16x squared minus 5 over 4x plus 25 over 4. So we can factorize the x squared, which we get 1 over 4 pi plus 1 over 16 x squared minus 5 over 4x plus 25 over 4. Then we can differentiate the a in terms of x. Hence, dA over dx equals 2 bracket 1 over 4 pi plus 1 over 16x minus 5 over 4. Then we derive second time, which we get d squared a over dr squared equals 2 bracket 1 over 4 pi plus 1 over 16. And from here, we find that d squared a over dr squared is positive. Therefore, a is minimum. So we have shown that it is minimum. Now, we let dA over dx equal to 0, which means 2 bracket 1 over 4 pi plus 1 over 16x minus 5 over 4 equals 0. And we want to solve this equation. Hence, 1 over 2 pi plus 1 over 8x equals 5 over 4. Alright, so we times 8 for both sides. Then we get 4 over pi plus 1 x equals 10. Or 4 plus pi over pi x equals 10. Hence, x equals 10 pi over 4 plus pi. So the radius r is 10 pi over 4 plus pi divided by 2 pi, which we get 5 over pi plus 4. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.